right, example number 4 for mixture problems. The chemist mixes 12 liters of a solution that is 45% acid with 8 liters of a solution that's 70% acid. What percent acid is the mixture? All right, so this one's a little different, but try to set up your table, and I'm going to pause it here, and then I'll show you the table when you get back. All right, so this time, let's see, we're mixing 12 liters of a solution that's 45%, so we have a 45% solution. I'm going to abbreviate solution, okay, with 8 liters of a solution that's 75%, or excuse me, that's 70%. Okay, so 70% solution, and then we have our mixture, right? And we don't know what percent concentration it is. Okay, so anyway, so I told you earlier that a lot of times amount is your X, but this time we're looking for the concentration, right? We're looking for the percent concentration, and we're measuring percent in terms of percent acid, right? So let's keep that in mind. So percent acid. Okay, so what we do know is we know the amount, right? 12 liters of the 45% solution. Let me put L up here for liters, and then we have 8 liters of the 70% solution. So what do you think how many liters do we have altogether? And you guessed it, 20, right? And in case you need to see where that came from, it's 12 plus 8, right? Just added these, the two rows together. All right, so we also know something about the concentrations, right? We know that we have a 45% concentration here, and we have a 70% concentration. So let's convert those to decimals. So it's going to be 0.45, right? Whenever we operate with percents, we want to make sure we put them in decimal form. Okay, now here's the tricky thing is we can't just add those to get here, right? Because 45% plus 70% is 115%. That doesn't make sense, right? We can't have more acid than we do the substance itself or the solution itself, right? Okay, so percentages or concentrations when you combine them, remember that we're going to get something in the middle. So we're going to get something between 70 and 45%, right? Something that's more concentrated than the 45%, but less concentrated than the 70%. All right, so now we can, well, actually, here I'm going to put X for the mixture, right? That's what we're trying to find. So I'm going to put X for the concentration of the mixture. Okay, so now that we have our first two columns filled out, let's fill in our last column by multiplying. Okay, so I'll let you do that. I'm going to pause for a second and then jump right back to it. All right, so I multiplied the concentration times the amount, and that equals the value. So what I have here is 5.4, right, plus 5.6, and that has to equal our mixture, right? So if I add the two components, that's going to equal the mixture. So that's the relationship. So our equation is 5.4 plus 5.6 equals 20x, right? Okay, so now I'll let you solve it from there. But I'm going to freeze it and do the math, and then I'll come back to it. All right, so here we have a decimal answer, and you might be wondering, did we do something wrong? And the answer is no. Remember, we're looking for the percent concentration, right? And so we actually found it, right? We found the answer as a decimal, so we want to convert that to a percent. So it'll be 55%, right? And that is the concentration of the mixture, right? 55% acid, and that's the concentration of the mixture. All right, so send questions my way, and keep working hard.